Okay, so in the last video, BMAPhysics 3C, we did an example triangle, and so we are going to do another example triangle in this video. And so what we're going to do is we're going to mark a point, say right there, and we're going to put the protractor on the axis, and let's just say 55 degrees. So there's 55 degrees, and so we're going to go some distance in that direction, and we're going to call it, let's say 12. So we're going 12 in, so we're going 12 centimeters at 55 degrees. And let's make that into a right triangle. So we've done it there, about, and right there. Okay. So this is 55 degrees, and that's my 90. And because we know that 90 plus 55 plus something equals 180, we know this plus 90, or this plus something else equals 90. So if I do 90 minus 55, I should get 25 degrees. I checked that, and I don't quite get that. I gotta make it 35 degrees. So we know that that's going to be 55, that's going to be 35 degrees. Now let's use trigonometry to find this side and to find that side. Okay, so we're going to find our 55 is right here, and we go no, and we say that this is opposite. This is my hypotenuse, and this is my adjacent. Okay, and so what we're going to do is we're going to say, the sine of theta is going to be opposite over hypotenuse. Now if we know theta and we know hypotenuse, we're going to solve for opposite. We're going to rearrange that. We're going to say hypotenuse times sine theta equals opposite. So we're going to have 12 centimeters sine 55 degrees is going to be equal to, on the calculator, we have 12 sine 55, and we're going to get 9.8 centimeters. Okay, now similarly we're going to say that cosine theta is equal to adjacent over hypotenuse, and so we're going to say that adjacent equals hypotenuse times sine theta, and so we're going to say our adjacent is going to be 12 centimeters times sine of 55, cosine of 55 degrees. Cosine of 55, oh crap, come on, that's cosine. Sorry for the confusion. Adjacent equals hypotenuse times cosine theta. Adjacent equals 12 centimeters times the cosine of 55 degrees. So on the calculator, I do 12 cosine 55, and I get 6.9. So adjacent is equal to 6.9 centimeters. Okay, so if I measure across, I see that 1, 2, 3, 4, 5, 6, 7 Right now I've got it measured at 7, which is pretty close to 6.9 for my adjacent, and going up in the vertical direction for my opposite I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9, and I don't quite get to 10, so I'm at 9.8. So I'm going to say that this is 9.8 centimeters, and this is going to be 6.9 centimeters. Okay, and so there's a lot more that I could do with all kinds of different triangles, but this, in those last two videos, 3C and this one, 3D, we're giving you just an introduction on how to use sine, cosine, and tangent in the Pythagorean theorem to solve right triangles.